A lot of the buzz in exoplanet research these days is being caused by a small satellite that NASA operates, called the Kepler mission. It's a 1-meter telescope in Earth orbit that has only one purpose: to detect transits or eclipses of exoplanets. It does this by staring at about 150,000 stars in one region of the sky, over and over again. Its PI Bill Barucki of NASA says it's the most boring mission ever designed. It basically looks at that same large number of stars every few minutes and will do so for years and years, and that's all it does. But it's perfectly designed for its job. By staring at a large number of stars, it will find transits even though they're statistically rare. By working outside the Earth's atmosphere, it has the stability to detect tiny variations of a few parts in 100,000 in the light from a star. And by its persistence, it can find transits corresponding to Earth planets in Earth-like orbits of their stars. Data taken within the first few weeks of the Kepler mission showed that it could meet or nearly meet its design goals. The noise here for a transit of a star on another star shows incredibly small noise, at 1/100%, what's required to detect Earth's. It turns out there were subtle systematics and noise in the Kepler detectors that stop it from reaching all of its targets within its original 3.5-year mission. So Kepler has been extended for 3 more years and will keep taking data till about 2016. A family portrait of the stars and exoplanets that Kepler has detected, just a sampling, not all of them, shows the primary method of its detection, the slight shadowing of an exoplanet as it passes the face of its star. Kepler has to take data every few minutes for years to detect these rare transits. Moreover, it needs to confirm the transits and show they're not statistical flukes, fluctuations, or noise in the detector. For it to be a confidently detected transit, Kepler requires the signal to be seen 3 times, which requires at least 2 full orbital periods. Within the Kepler project, they've created a visualization of the little orbits of these systems. Most of them are rapid orbiters, completing their orbits with periods of days or weeks or months. The size of the planets and the size of the stars are represented relatively in this animation. Sometimes science fiction anticipates true science. In one case, Kepler has found planet orbiting a double star, and such planets may be common. This, naturally, has been called the Tatooine planet.
NASA's Kepler mission has made the first detection of a planet orbiting 2 stars. About 200 light-years away from our solar system, the planet Kepler 16b orbits 2 of the 150,000 stars that the spacecraft is monitoring between the constellations of Cygnus and Lyra. Kepler detected the planet directly through what is known as a planetary transit, an event where the brightness of a star dims as a result of a planet crossing in front of it. Planets orbiting double stars have been a favorite of science fiction writers for a long time, the most famous of which is from the 1977 movie Star Wars, which showed a double sunset viewed from the fictional planet of Tatooine. Until now, astronomers did not know if such planetary systems could actually exist. Because of Kepler 16, astronomers have confirmed that the double sunset seen by Luke Skywalker is possible. The planet Kepler 16b is cold, gaseous, and about the size of Saturn. Its stars are both smaller than the Sun and about 2 billion years younger than our solar system. They orbit around each other, so from our vantage point, they take turns eclipsing each other about every 41 days. The planet Kepler 16b orbits around both stars every 229 days. It is outside of the habitable zone of the stars, which is the region where temperatures are right for liquid water to exist on the surface of the planet. Since it is made of gas, Kepler 16b may not harbor life. But there is evidence that rocky planets with double sunsets are common in our galaxy. And the discovery of these by the Kepler mission are helping to turn science fiction into science fact.
As with the Doppler method, the transit method has found a lot of giant planets, including many hot Jupiters. With Kepler, persistence will be required to detect Earths, because it will take the Earth 2 years to show a double eclipse, so Kepler will need that amount of data before it can confirm an Earth-like transit of a Sun-like star somewhere else. If we watch the steady accumulation of Kepler planet candidates over the first couple of years of its mission, we can see how it succeeded amazingly in detecting Earth-size or smaller planets. Remember, Kepler on its own only detects the size of a planet, not its mass. The mass would have to come from a second observation to detect the reflex motion by the Doppler shift. With the march of time, you see the candidates moving towards the lower right-hand corner of the graph, where the Earth would lie with a 365-day orbit. Kepler will need to have taken data for 3 years before it will find an Earth in an Earth-like orbit. So far, it's only managed to find Earths in much tighter, hotter orbits around their stars. The mission, however, has been extraordinarily successful, even though it's not complete. At this point, it's found over 800 super-Earths, or objects with sizes a couple of times the Earth's size, or masses 2 to 5 times the Earth's mass. And it's found over 300 Earth-sized planets, expected to be Earth mass as well. And this in a situation where only a few years ago we knew none. The exoplanet zoo from Kepler shows many objects: Neptunes, Jupiters, Earths, hot Jupiters. All that's missing are Earth clones. Kepler is a phenomenally successful NASA mission designed to detect exoplanets by their transits or eclipses. It's already found several thousand exoplanets and is due to take data for another few years. It's found several hundred Earth-sized or smaller planets and is heading towards the goal of Earth-like planets at Earth-like distances from their Sun-like stars. Think about it. For $400 million, you could have James Cameron's movie Avatar, which talks about life on an Earth-like moon around a planet, or you could do the actual scientific experiment of finding Earths in distant space.